Dimensions, with dealing with overall dimensions, refer to the following details and diagrams. A is nothing but the width of largest stamping. This is here I have taken one the single phase core type cruciform core or a two-step core. A is nothing but width of largest stamping. Largest stamping mode, this is your width of largest stamping of your core. It's nothing but your A. You can see width of largest stamping A. Or if you want to see for a cruciform core, you can see here, this is nothing but a width of largest stamping A. Okay, you can see here, this is a cruciform core or two-step core or a two-step core. Okay. This is nothing but width of largest stamping. Okay, this is nothing but width of largest stamping. Then D is nothing diameter of a circle. D nothing but the diameter of a circumference circle is nothing but this D. This is nothing but this D. This is nothing but the diameter of a circumference circle. This is the D. And D is the distance between the centers of adjacent limbs. These are the two limbs, and this is the yoke part, and this is the upper yoke part, this is the lower yoke part, and these are called as limbs. These are called as limbs. Limb. So, what is the capital D? Capital D is nothing but the adjacent distance between the two limbs. Adjacent distance from the center of the two limbs. This is your D. Okay. Then WW is something about the width of the window. HW is something about the height of the window. Okay. H is overall height of the transformer. Overall height of the transformer. Overall height of the frame. This is H. HW plus 2HY. And W is nothing but this is W. Nothing but the length of the yoke or overall length of the frame. Length of the yoke or overall length of the frame. So if you see here, D is something about WW plus D. This is D. How do you calculate D here? The width of the window plus here half D plus half D. You will get what? Full D. Then dy, depth of the yoke. Depth of the yoke is something about the width of largest stamping. So depth of the yoke, if you go to the three-dimensional view, depth of the yoke of cruciform core, this is depth, this is height. So depth of the yoke will be what? Width of largest stamping. Depth of the yoke will be equal to depth of the core. That will be equal to width of largest stamping. Okay. So dy is equal to A, and H is equal to, as you know, HW plus 2HY, and W is overall D. D is nothing but what? D plus A. So this is D, this is W, overall length of the frame or overall length of the yoke. Okay, then this is D. Then here I want up here. This distance is left for, this is after the core part, what you got here, you got the gap here. That gap also you have to consider. Okay, here. So W is nothing but what? Up to here. So what you get here? WW plus, if you get what? WW plus up to here I got it. So I can calculate what? I can calculate here D plus I can up to here this D. Then what you get here? You can get here another halfway it will be full A. So W is equal to D plus A. Okay, this is D here halfway plus halfway will get what? Full A. That is for a single phase core type. Likewise, you go for a single phase, three-phase core type. Everything remains same. Only the width will change. The width is something called here 2D plus A. 2D to this is overall width. So 2D means here 1D, 2 plus halfway. What you get here? 2D plus A. Other things will remain same. Okay. Likewise, if you go for a shell type transformer, you can get that. Once again, this will be what? This will be height of the yoke, and this will be depth of the yoke. B will be depth of the yoke. Okay, this is nothing but a core part, and winding is done on the central link. Okay, dy is nothing but what? Depth of the yoke. This is the depth, and this is the width. The depth of the yoke will be 2A. So the width of the central link will be twice the width of side link. In a shell type transformer, the width of central link will be twice the width of the side lane, and depth will be B. This is the depth, you can see here. This is the core part, and this will be B. So dy is equal to B. Height of the yoke. This height of the yoke will be A. Nothing but the width of your side limbs. Height of the yoke, and W is equal to the overall length of the frame or overall length of the yoke will be what? Overall length of the yoke. This is overall length W. How do you calculate here? This WW plus WW, 2WW plus 2A plus A plus A. So what you get? 2W plus 4A. And height of the window is nothing but HW A plus A, 2A. So HW plus 2A. So these relations you are going to use by finding out the overall length of the window and overall length of the height of the window. Okay. Now come to for today's class. What are the simplified steps for transformer design? So you have to follow a certain design procedure, so it will be easy for you to calculate, or the flow will be easy for you. What is the first step? Calculate EMF per turn or voltage per turn using the formula. It is equal to K divided by K under the root of Q. Okay, this we are already proved. EMF per turn, and also it is equal to what? 4.44 for FM. Okay, 4.445 FM. Either you can use these two formula. Any of the one formula you can use for calculating the voltage per turn. Find the net cross-sectional area of the core AI from the equation. What is AI represent? AI is nothing but the net iron area. AGA is nothing but the gross iron area. Gross iron AGA includes both the iron part and insulation, where AI includes only the iron part. So it is equal to 4.4 for F 5M. 5M can be written as what? BM into AI. So AI you calculate, AI is equal to ET divided by 4.44 F into BM meter square. And determine the diameter of the circumference circle using the formula. Now normally you can use this one. AI is equal to Kc into D square, where T is equal to the root of A by Kc, where Kc is called as a core area factor. Rarely you use this formula. Okay. Find the width of the window from the equations that we can use. Find the width of the window. So you got D here. D is equal to W plus D. From that relation you can use. So you got it here. You got it here. D is equal to WW plus D. So from that you can use what? I can find out the width of the window. So WW is equal to D minus D. That you can find out. D minus D. And then how to find out this D? We know that we know that D is equal to what? 1.70. In the theory while explaining, we have proved this one. The distance, the distance between the adjacent center of the adjacent limbs will be what? 1.7 D. I think we have one direction Ekesani. If you want, you can go through it, but it's not important one. You can go through it. D is equal to 1.7 D, where small d is nothing but the diameter of circumscribing circle. Okay. Then step 5, obtain the window area from the following equation. For single phase transformer, this is your output equation. So from this output equation, we can find out what? We can find out the window area. This is for single phase. For 3 phase, only difference is what? Here 2.22. Here what we got? 3.33. That is regarding to find out the window area. Find height of the window. So area of the window is nothing but what? Height of the window into width of the window. So from that I can find out what? Height of the window. Also, the ratio of height of the window to width of the window lies between 2 to 4. We are discussing theory, I think in previous class. The height of the window to width of the window is what? 2 to 4. Normally, you are going to take in between value, that is nothing but your 3. Okay. Obtain the depth and the height of the yoke for stepford core. For 2 stepford core, dy depth of the yoke is equal to A. If I go here, 2 stepford core, depth of the yoke. For square, it will be A, both will be A and A. Height and width will be both A and A. For rectangular yoke, it will be A or this will be D. It will be different. For cruciform core, even depth of the yoke will be A, and even the height of the yoke will be A. You can see. So area of the yoke is something but what? Depth of the yoke into height of the yoke. That will give you area. Okay. So dy is equal to A, height of the yoke is equal to A, where A is nothing but width of largest stamping. Then this is nothing but find the overall height and the length of the frame of the following relation. As I discussed now itself for single phase, 3 phase, and shell type transformer. Okay, and these are the simplified steps to find out what to design the transformer. Okay, with this background, let us go for solve some problem and find out regarding WW and HW, height of the window, width of the window, and overall H and overall W. Okay, come to problem here. Determine the dimension of the core. Determine the dimension of the core and the yoke. Determine the dimension of the core and yoke for 200 kVA, 50 Hz, single phase core type transformer. A cruciform core also equal to a 2-stepford core is used with the distance between the adjacent limbs equal to 1.6 times the width of the core lamination. 1.6 times the width of core lamination. That is a condition. Assume voltage per turn 14 volt, maximum flux density 1.1 Vapor per meter square, window space factor 0.32, current density 3 ampere per mm square, stacking factor is 0.9. Okay, the net iron area is 0.56 d square. Okay, this net iron area is equal to AI. AI is equal to 0.56 d square. I think we have proved for this one. You have proved in the previous section. AI is equal to 0.56 d square. If you go back to the previous classes, I think I have shown one table. Okay, this is a table. Okay, for square, for cruciform, for 3-stepped, for 4-stepped. This is the ratio, and this is AI. AI for cruciform core, you can see here, AI is equal to what? 0.56 d square. We have done analysis for square and cruciform core. Like that, we can do analysis for 3-stepped and 4-stepped core. Okay. That is given 0.56 d square. In the problem, they may mention 0.56 d square. Otherwise, you should remember this value. Net iron core area. A is equal to 0.5 d square. In a cruciform core, where d is the diameter of a circumscribing circle and also the width of largest stamping. The width of largest stamping A is equal to 0.85 d. This also we have done while solving theory. While explaining the theory, we are told regarding what? We are told regarding this A. For cruciform core, we done analysis for cruciform core. You can see here A is equal to what? A is equal to width of lot. We are going to find out this A and B. So what is A now? If you come back here, you can see here A. A is equal to d cos of 31 degree 45 seconds. What you got here? 0.85 d. Normally in the problem they specify all the parameters. If they're not specified, try to remember these things. A is equal to 0.85 d. Okay. So what you have to find out? You have to find out the dimension of the core. Dimension of the core means core area means if you take cruciform means what? The width of largest stamping is what? The width of largest stamping is A. That I have to find out. Even the width and the depth. The width means this is nothing but A, and this also will be A. In the cruciform core, this is A, and even the depth of the core also will be A. So you have to find out A. Along with that, you have to find out the main dimensions. Main dimensions means you have to find out the HW, you have to find out WW, you have to find overall H, and you have to find out overall W. And along with that, you have to find out the yoke, height of the yoke, depth of the yoke, and area of the yoke. You have to find out. These things you have to find out using this data. Let us find out. Voltage per turn, ET is equal to 4.44 F5M. F5M can be written as what? VM into AI. Calculate AI. AI is nothing but what? Net iron area. Net iron area of the core. Core means entire this part. Core means entire this part, including the yoke and including the limb. Okay. Net iron area of the core, AI is equal to 0.56 d square. So 0.56 d square. So d square, find out d. D square is equal to AI by 0.56. What you got here? 0.102. What is d? D is equal to 0.32 meter. What is d? D nothing but what? The diameter of circumscribing circle. It is d. Okay, now. The width of largest stamping. The width of largest stamping A is equal to what? 0.85 d. So 0.85 d, substitute for d, and what is the width of largest stamping here is equal to 0.272 meter. So you find out what now? Width of largest stamping A is equal to 0.272 meter. There is nothing but what? The width of largest stamping, or what we call as the dimension of the core. Dimension of the core. Okay. Even this is the width and that is the height. Both will be same. Now, distance between the center of adjacent limbs. What is given in the problem? You can see here. The distance between the adjacent limbs is equal to 1.6 times the width of the core. So we calculate the width of the core. What is the width of the largest stamping? A. And think about what? 0.272. So distance between the center of the limbs D is equal to what? 1.6A. What is the A here? 0.272. So 1.6 times the width of the core. Okay. 1.6 into 0.272. So what you got here? 0.435 meter. Once you got D, and you can calculate what width of the window. Using the relation, D is equal to WW plus D for single phase. The WW is equal to D minus D. Substitute for D and capital D and small d. And what you got here, AW is equal to 0.115 meter. So once you got width of a window, I can use the output equation. Q is equal to 2.22 FPM EI KW AW delta 10 power minus 3 kVA. And I'll calculate the area of the window. What is the area of the window here? You calculate here 200 divided by, substitute all the values. Substitute for frequency PM, is substitute for AI. Okay, AI you calculate here. What is AI here? 0.0573. And that's substitute for KW. KW is something about window space factor. Window space factor is given in the problem 0.32. All the values you substitute here, and here current density. What is current density given? Current density is you can see here what is current density, 3 ampere per mm square. So convert it to meter, ampere per mm square. So this is very much important one. 3 into ampere per mm square. So it will be in denominator 10 power minus 6. I have taken into numerator. So this is very much important one. Don't check here. Ampere per mm square. So 10 power minus 6 I have taken into numerator. So 3 into 10 power 6 into 10 power minus 3. This is 10 power minus 3. Solve this one. What we got? 0.0298 meter square. So you know that area of the window is something but what? Height of the window into width of the window. So using that relation, height of the, already we know width of the window. So height of the window is equal to what? AW divided by WW. What I got now, height of the window, 0.26 meter. So this is what? The dimensions of the window. Then you can calculate what? You can calculate depth of the yoke. For cruciform core, depth of the yoke, once again I show this three-dimensional view, depth of the yoke. This is depth, this is height, both are A. Depth of the yoke is equal to A and height of the yoke will be A. Okay. So depth of the yoke will be A, it's nothing but 0.272. Height of the yoke, HY is equal to A, is nothing but 0.272. Then you can find out overall height of the frame, H is equal to HW plus 2HY. And overall length of the frame, W is equal to D plus A. Okay. Then you can find out. This is a simple problem. So normally a problem will be easier with respect to transformer. So this is a first problem. Likewise, we'll go for a second problem. Design 250 kVA, 200 bar 400 volts, 50 hertz, single phase core type oil immersed self cooled power transformer with the following data. Induced EMF per turn, maximum flux density in the core 1.25, window space factor 0.3, current density delta is equal to 2.75 ampere, and the given window proportion height by weight. So normal height of the window divided by not this weight and this is width. Okay, just change. I'll change this one. Height by width. Height of the window divided by the width of the window. Think what? It lies between 2 to 4, so it is 3. Okay. Determine the main dimensions of yoke and core. Once again, same thing. Yoke and core. Assume 3-stepped core. Really, what they give? But assume 3-stepped core. If you see the figure, this is called as what? This is called as your 3-stepped core. Okay. This is rectangular core. You can see this is square core. This is a cruciform core or 2-stepped core, and this is called as a 3-stepped core. Okay. Let us solve the problem. The same step you can do it. Voltage per turn 4.44 F5M. Okay. Vm into AI, calculate AI. AI is equal to 0.054 meters per second. Put the things, calculate. For 3-stepped core, the net iron area AI, the net from the table you can take it. The net iron area AI is equal to 0.6 D square. Normally in the problem, they'll give the value 0.6 D square. Otherwise, try to remember this one. Okay. The net iron area AI is equal to 0.6 D square. Okay. D square is equal to A by 0.6. So what is D? D is equal to 0.3 meter. Width of largest stamping, A is equal to 0.9 D, because we are not done analysis for 3-stepped core. So if you do the analysis, then what you get, A is equal to 0.9 D. In the previous problem, we have shown that width of largest stamping A is equal to 0.85 D for cruciform core. That we have done the analysis. But likewise, you can do the analysis for 3-stepped core. So what? Just remember this formula. A is equal to 0.9 D. Normally these things they are doing the problem itself. Otherwise, try to remember. So 0.9 into 0.3, 0.27 meter. Once you find out A, then from the output equation of a single phase transformer, you find out AW. We show here, this is 10 power 6 ampere per mm square. Okay, with respect to current density. So put the values and find out AW. And you know that this is also 3, it's not 33, it is 3. I will just make the correction here. Height of the window divided by width of the window is equal to 3. So there is 3, not 33. So height of the window is equal to 3 times the width of the window. They give the condition, height of the window by width of the window is equal to 3. And also we know that what area is equal to height of the window into width of the window. And what is the area of the window here? 0.404. And we know that height of the window is something about 3 times width of the window. Substitute here for HW. So what we get here? 3 WW square is equal to 0.0404. okay, 404 meter square. Then WW is equal to 0.116 meter and HW is equal to 0.34 meter. And once again, the depth of the yoke for 3-stepped core. If you go for 3-stepped core, what is the depth? The depth will be A, and width of largest stamping also will be A. Okay. So depth of the core dy is equal to A, 0.27, and height of the yoke hy is equal to A, 0.27. Then for single phase, once again, this formula already you know, overall height of the frame, overall length of the frame, HW plus 2H5, W is equal to D plus A, then substitute the, here W is equal to D plus A. So D I don't know here, because the distance between the adjacent limbs in this problem, it is not there. So use another way of finding out what? Finding out for D. If you come back to the figure here, D is here. I want D. So if I want, okay, you come here itself. If I want D, so I want D means, since D is not given. So what is the other way of finding out D? I can use what? I can use this WW. You can see here, this is WW. This is WW. Okay, width of the window. Plus, you come here. Width of the window. Then so overall, I think what you require there. Okay. Okay, I require what? If they're not given D, then you can use what? Then you can go for this figure and find out here. Okay. So D I want, WW I know, WW plus half D plus half D. What you get? You get full D. So this D is nothing but WW plus half D plus half D. That you can use it. Okay. If you don't know the value of D is nothing but what? The distance between the adjacent limbs, adjacent limb, the distance between the center of the two adjacent limbs. So WW plus D plus A. The WW I know, D I know, and A I know. So put this one and 0.686. But in previous problem, directly I have calculated based on the data, D is already there. Otherwise, you use this formula WW plus D plus A. Okay. This is what once again a simple problem, a second problem. Just you go for a third problem. Let us see. Calculate the approximate overall dimensions of 200 kVA, 6600 watts, 400 volt, 50 hertz, 3-phase 4-type transformer. The following data may be assumed. So once again, there you all the data here. Okay, EMF for turn, flux density, current density, and what is the condition given here? Overall height is equal to overall width. Overall height of the window is equal to overall width of the window. Stacking factor is given. Use 3-stepped core. Okay, for a 3-stepped core, width of the largest stamping is what? 0.9 D. You can see here in this problem they given the data also. Okay, width of largest stamping 0.9 D, and net iron area is equal to A is equal to 0.6 D square, where D is the diameter of circumscribing circle. Draw the sketch showing the details. So as to draw the sketch means you have to draw these things. You have to draw the sketch of this figure. Okay, instead of 3-stepped core you're going to use and draw this figure. Okay, now we draw this figure. If they ask to show the details, let's calculate now. So once again, we have to calculate overall dimensions of the core and overall dimensions of the yoke. In the same steps you calculate here. Voltage per turn, calculate voltage per turn. For 3-stepped core, A is equal to 0.6 D square, calculate D. Width of largest stamping, A is equal to 0.9 D, calculate A. And you come for the output equation of a 3-phase transformer, find out AW. And AW is equal to H into WW. The area of the window is nothing but HW into WW is equal to what? 0.0355. After finding up to here, they are given the condition that what? Overall height of the window is equal to overall width. That means what? H is equal to overall height. Overall height means overall height is not overall height of the frame. Overall height of the frame, not height of the window. It is a frame. Overall the height of the overall height of the frame and overall length of the yoke or length of the frame. Okay, these things they are given. Overall height of the frame or overall length of the frame. Okay, overall height and overall length. So what is this one now? Overall height H is equal to HW plus 2H5 and W is equal to 2D plus A. So these are things. Depth of the yoke you calculate. Dy is equal to A, 0.216. Height of the yoke, Hy is equal to A, 0.216. This is required same. Then come back to here. Take overall height of the frame. H is equal to HW plus 2HY. Separate for HY here, 0.216. HW is equal to 0.432. Take the equation 1. Take second equation W is equal to 2D plus A. Then separate for A. D is nothing but for WW plus D. And you calculate here, substitute and calculate 2WW plus 2WW plus 0.696. This is equation 2. But H is equal to W. H is equal to W. So equate equation 1 and 2. HW plus 0.432 is equal to 2WW plus 0.696. So HW is equal to 2W, just simplify this one. And here 2WW plus 0.264 HW is equal to HW means area of the window. We already calculated area of the window. Area of the window it. Substitute for HW. Okay. Substitute for HW. Okay. So if you substitute for height of the window 0.035 divided by this is area. Substitute for HW. HW is nothing but area by WW. Area of the window 0.0355 divided by WW. Then solve this. Simplify this one. 2 WW square plus 0.264 width of the window is equal to 0.335, and this is your quadratic equation. And you can find out the roots, and you can find out what WW is equal to 0.083 meter, and HW is equal to. So once you find out WW, then you can use HW. You can use here HW, and you can find out HW is equal to 0.428. Okay, you can use any other equation here, and you can find out. And you can find out what? You can find out HW. Okay, this is what. So once you find out WW and HW, then you can find out what? You can find out overall length of the frame. Okay. Here you will get WW, HW from area of the window. Area of the window is something about height of the window into width of the window. Area of the window WW then you find out HW. Okay. Now overall height of the frame, H is equal to HW plus 2HY. Substitute the values here, HW 2HY, then you get the answer. Overall length of the frame, 2D plus A. D replaced by WW plus D plus A. Then you get this value. Okay. This is one a little bit. Not I'm telling tougher one, but a different problem compared to the first two problems. Okay, let us go for one more problem with this. See, still I'm doing with what? Still I'm doing with only the dimensions of core and yoke. In next class, I will deal with the binding details. Okay. Determine dimensions of core and yoke for 100 kVA, 50 Hz, single core type transformer. A square core is used, the distance between the adjacent limbs. Square core here, the square core is used. The distance between the adjacent limbs is equal to 1.6 times the width of the lamination or width of the core. Assume the voltage per turn equal to 14 volt. Maximum flexibility is 1.1 Wb per meter square. Window space factor is 0.32. And current density is 3 ampere. Stacking factor 0.9. Flux density in the yoke to be 80% of the flux density in the core. They are given the condition here that the flux density in the yoke to be 80% of flux density in the core. What's the meaning of that one? If you go back to the figure, so if you go back to back to the figure, see, this is called as an entire core. Core means what? It has got two parts, yoke and limb. So this entire part is called as a core. So the flux density in the core and the flux density in the yoke. This part is yoke and this part is yoke. And including the limb, it's called as a core. So the flux density in the yoke is what? 0.8 times the flux density in the core. Whatever the flux density in the core, okay. So the flux density in the yoke means both, including the upper part and lower part. Flux density in the yoke is 0.80% of flux density in the core. That is the condition. Okay. This is very much important problem. This one, and this problem they ask several times the same problem. So what is the main difference here? They have given the condition that flux density in the yoke to be 80% of flux density in the core. So yeah, this is the condition. So based on this data given, I will try to calculate what second dimension of the core and dimension of the yoke. Once again, what they are given here, a square core is used. A square core is used. Yeah, this I'll change it here. So between the adjacent link. Square core, this is for square core. So whatever mistake I have made it here, I'll change it because cut and paste, I left as it is. This I'll do it. For giving the notes, I'll make it I'll make corrections. Okay. Square core. This is square. It's not the step core. It's a square core. Okay. Voltage per turn, ET is equal to 4.44 FIM. So 4.44 F into PM into AI. AI is equal to ET divided by 4.44 F into PM. Calculate AI. A is equal to 0.0573. This is for square core, not 3-step core. Square core net error area AI is equal to what? 0.45 T square. This is, you can I done the analysis for this one. And I put these values in the table. Okay. A is equal to 0.45 D square. D square, then you calculate T. T is equal to what? 0.357 meter. Width of largest stamping of square core. A is equal to 0.71 D. This I have done the analysis. A is equal to 0.71 D. This I have to remember it. Okay. A is equal to 0.71 D. So 0.7 into 0.357. So what we got here? 0.253 width of largest stamping. And in the problem, it is given the condition that now, according to the condition, the distance between the adjacent, the distance between the center of the adjacent of two limbs is equal to what? D is equal to 1.6 into 1.6 times the core lamination. This is core lamination A. 1.6 into A. So 1.6 into 0.253, 0.495 meter. So D you got it. Then you can calculate, once you got T, I can calculate what? Width of the window. Width of the window is something about what? T minus D. So 0.405 minus 0.357, what you got here? 0.048 meter. Okay. Once you calculate WW width, then you go for output equation. From that, you can calculate what? You can calculate AW. AW is something about what? HW into WW. And once you know area, once you know WW, I can calculate what? I can calculate the height of the window. Height of the window is something about what? 0.35 meter. But regarding the yoke, still I have to find out what? Still I have to find out the yoke, yoke dimensions, height of the yoke, depth of the yoke, and area of the yoke. And what the condition given? It is given that the flux density in the yoke, is equal to what? 80% of flux density in the core. So flux density in the yoke can be written as what? Flux density can be written as what? Flux by area. So phi m by AY. And 0.8 into, once again, flux density in the core. Phi m by AJ. Why have written AGI here? AGI is equal to what? Cross core area. Because if you go to the problem, they is given in terms of what? They give given the stacking factor. They give stacking factor, taking stacking factor of 0.9. If they give stacking factor means, then you have to consider AGI. What is AGI? AGI is something about the cross area which includes iron part and also includes the insulation. Okay. So phi m by AGI. So then we saw this phi m get cancels. The AY is equal to 1 by 0.8 into AGI. 1 by 0.8 is nothing but 1.25 into AGI. So area of the yoke will be what? 1.25 into AGI. Let us calculate this AGI. We know that AI, net error area, is nothing but what? KS into AGI. Calculate AGI. The AGI is equal to what? AI divided by KS. The AI already calculated here. AI is what? 0.573. So 0.573 divided by 0.9, what you get? 0.0673. Once you call glass core area, then I can calculate what? I can calculate the area of the yoke. Yoke area is 1.25 into 0.0673. So what you got here? 0.0796 meters square. Once you got area of the yoke, I can calculate depth of the yoke. So for a square core, the depth and the width will be A. For square core, it will be same. For square core, if I go back to the figure, this is square core. The depth, the width, and the depth will be both A and A. This is A and this is A. For rectangle, it will be different. Width will be A and depth will be B. Okay. For square, it is A and A. So you can go there. So depth of the yoke is equal to A is equal to what? 0.253. Once you know depth of the yoke, I know area of the yoke, I can calculate what? I can calculate the height of the yoke. Height of the yoke is nothing but AY divided by DY. Okay, because area of the yoke is nothing but what? Height of the yoke into depth of the yoke. So then what you got here? 0.315 meter. After finding out these things, you can find out the overall height of the frame. H is equal to HW plus 2HY. Overall length of the frame, and W is equal to D plus A. So here already I got it D, so I can directly find out. If you don't know D means, then you use WW plus D. That relation you can do. You can use it. W is equal to D plus A, so 0.405 plus 0.253, 0.658 meter. Okay. So this is what the analysis of the simple calculations how to find out the overall dimension of the core and the dimensions of the yoke, and along with that, you have to find out the height of the window and depth of the window, overall height of the frame, or overall length of the frame. Okay. These four problems relate to what to find out the core dimensions, core dimensions, and the your dimensions, overall dimensions of your frame, that is height and width. Along with that, you will try to find out your HW, height of the window and depth of the window. So with this, I stop at this point.